Hello, dear viewers. In today's video series, we're going to look at the comets that roam the depths of space and inspire many science fiction stories. What are comets? Where do they come from, and how do they form? We will discover the answers to these questions together. What are asteroids and meteorites? Before we talk about comets, let's define two celestial bodies that are often confused with them. Asteroids are small planets orbiting between the planets Mars and Jupiter and number about 40,000. These small planets are also known as planetoids because of their mass and volume. Some of them also have moons. Meteorite materials falling from space to the Earth's surface are called meteorites. When they enter the atmosphere, they burn up and leave a bright trail, which is why they are often called shooting stars. What is a comet? Although there are many of them, they are icebergs, which are a thick shell surrounding the sun, the Oort cloud, and have been known to exist since the formation of the solar system. They are bound to the sun by a very weak gravity. This means that the smallest gravitational fluctuations in deep space can cause them to deviate from their current position in the Oort cloud and travel into the inner solar system. The closest comet to us is 3 billion kilometers away, the distance between Earth and Uranus. Comets that can be seen with the naked eye in the sky above the Earth usually remain visible in the sky for a week to 6 months. In other words, comets are not objects that suddenly disappear from the sky as a beam of light. This is because they are often confused with meteors. In most cases, comets are faint in the sky. The visibility of such comets is greatly enhanced with a small telescope or even binoculars. Before continuing with the basic properties of comets, I would like to give a brief overview of our ancestors' attitudes towards these celestial bodies during their time on Earth, so that we can better understand the new properties of comets that have been obtained through improved technology and observation methods. The tendency to interpret any manifestation of comets as a message from the gods to the inhabitants of the locality permeated almost every comet record until the 16th century. In the 16th and 17th centuries, comets were viewed through the eyes of Aristotle, as gases, vapors, gases emitted by the Earth and perhaps the Sun, as well as the planets. Newton argued the opposite, that the bodies of comets, like those of planets, were compact, immutable, and durable. Newton concluded that the comet of 1680 produced a much more spectacular tail immediately after its sunrise than before it, and that the Sun formed the tail. These were logical enough explanations, but questions about comets, such as what their nuclei are made of, or what exactly is the thin vapor that forms the tail, were issues that Kant and many others grappled with at the time. As late as 1945, the leading American college textbook on astronomy unequivocally recognized that comets are scattered swarms of particles moving apart in parallel orbits in interstellar space. Some scientists believed that gravity held together this swarm of small meteorites, which were thought to make up the comet's nucleus, while others believed that there was not enough mass in the nucleus to hold them together, but rather that an enormous number of them were moving in the same orbit. This hypothesis explained why an aging comet would one day be replaced by a cloud of fine particles. According to this hypothesis, the swarm of sand particles that made up the comet was covered in a kind of more volatile solid that evaporated as it approached the sun, or the gases were covered in a kind of more volatile solid that evaporated as the rocks heated up, or the gases were gushing out as the rocks heated up. If this material was a thin layer enveloping a grain of sand, or if the gas was trapped just beneath the surface of a stony particle, it was hard to understand how much of this material could remain in place once it had passed close to the sun. Today, when several other comets, including Comet Encke, have been observed with the radar of a large radio telescope, they have been found to have a solid nucleus, not a swarm of particles. For another comet, however, there is evidence that the nucleus is accompanied by a swarm of debris. So there is perhaps some life left in the pebble pile hypothesis, but not as a replacement for the comet nucleus, but as an addition to it. Fred Whipple and the dirty ice ball model. He called refractory matter, that which can withstand high temperatures for a long time, dust, and volatile matter ice. and concluded that if the nucleus contained much more ice than the pebble pile model allowed, the question of why the nucleus formed could be solved. He showed that this view can be explained if we imagine the comet nucleus as a ball of dirty ice with mineral grains and possibly other materials scattered all around it. If comets are really made of dirty ice, then to understand comets we need to understand something about ice. Let us first assume that a comet is made of ordinary water ice. There are a remarkable 92 types of atoms in nature. The largest of these are hydrogen, helium, oxygen, carbon, and nitrogen. Since there is more hydrogen in the universe than any other type of atom, typical cold pieces of cosmic matter tend to be hydrogen-rich. Water ice is not the only ice that exists. If you take CO or CH4 gas and cool it sufficiently, they too will form a cold white solid. Now imagine a typical but more watery mixture of methane, ammonia, water, Colorado, and other gas molecules that general cosmic multiplicities bring to mind. For water to exist in liquid form, it would need to be almost as close to a sun-like star as the Earth is to the Sun. Temperatures beyond Saturn or on a tiny grain of dust between stars are very low, and a water molecule hitting this grain at speed would stick to it. As the grain passes through billions of years of thin interstellar gas, it grows, and the crystal lattice expands itself little by little in all directions. As it does so, other kinds of molecules, perhaps a methane or an ammonia or something else, can get trapped inside the lattice. This kind of water ice structure, in which foreign molecules are trapped inside the lattice, is called clathrate. The trapped molecule is not chemically bound to the ice, it is only physically trapped. In addition to the high concentration of water ice in the comet nucleus, CH4 ice, Colorado ice, and CO2 ice are also present. Since ice is not a good conductor, the comet's interior remains at the temperature of interstellar cold for a long time. The outside, however, is constantly warming up. The outer layers of ice separate from the comet and are blasted into space. Different ices are exposed to this violent vaporization at different temperatures and therefore at different distances from the Sun. However, most comet plumes have been observed to occur right around the asteroid belt. This in itself is evidence that water ice is the main volatile component of comets, and that water vapor and its breakdown products are the main constituents of cometary hair. In short, water ice is abundant in comets due to three factors: the abundance of water in the cosmos, the possibility that other flyers were lost during the first incarnation of the comet's orbit, the fact that water gushes out only when the comet is in the inner solar system, close enough for observers on Earth to see it. Conclusion: comets are one of the most mysterious and interesting remnants of the solar system. Their study gives us the opportunity to learn more about the depths of space. Thanks for watching. Don't forget to subscribe to our channel and like the video. See you in the next video. Bye!